Okay, so this section is about, this is 8.3 and it's about law of sines. And so this is law of sines right here. And it basically goes sine angle A over A, side A, angle B over side B, side of angle C over C. And so if I drew a triangle, and we'll make this one A, B, C. A is opposite. They're all opposite each other, if that makes sense. And so we have these different versions of triangles, and we're going to have two different laws. We have law of sines in this section, law of cosines in the next section. And you see we have 3 angles and 3 sides. And so we need to know 3 of those in order to be able to solve for the rest of the triangle. For the section coming up, if we knew all 3 sides, we'd want to use law of cosines. And if we know 2 sides in an angle, but that is side angle side, where the angle is in between, it's in between the 2 known sides, that's law of cosines. That's my cats fighting in the background. Hopefully they'll get over that soon. So then for law of sines, we have angle angle side or angle side angle. So this one is where we know 2 angles with a opposite side, and angle side angle, we have 2 angles and we know the side sort of connecting them. And in this case, what we can do is we can turn it into this one, because if we know 2 angles, we can figure out the third one by subtracting off a 180, since triangles have 180 degrees, and then we basically make it into this case. This is the one that is trouble. So this one can have, there's actually 3 outcomes for this triangle. So this is side-side angle. So it's the one where we know we have 2 sides, but we only have 1 angle, and it's not the one in between, which was law of cosines over here. So this one can have 2 solutions, 1 solution, or no solutions. On the homework, I think I have ones that have 1 solution, and then there's one with the ambiguous case where there's 2 solutions. I'm going to go through examples of each of those, and they're out of another book, so these ones aren't from your book. I like the examples in the other one better, so I'm using those. And so let's see what this all looks like. Okay, so here's this first problem. It's going to be the kind where we know 2 angles and 1 side. So that is these versions. And so what I can do, I have A and B. I can immediately get C really easy, because I just do 180 minus 40 minus 60. And that's going to be the third side of the triangles, because so I'm just 180 degrees total minus each of the sides leads to the last one. And so right there I know C that's 100, so C equals 80. So there's the first thing I needed to find. And then I need to find the other 2 sides. So law of sines again back here was sine of angle A over A equals the same thing in B or the same thing in C. So I'll use that to get the rest of this. So I know I have angle A and I have side A, so that means I can say sine of 40 degrees over 4 is going to be the same as sine of 60 degrees over the unknown side. And so what I'll do here is I'll multiply both sides by B. So let me show that. And I'm going to show this, I'll show this little solve one time, and then after that I'm going to shortcut it, so let me show it good this time. So what I'm doing is I'm multiplying both sides by B, and that cancels this out. So then I have B times sine of 40 over 4 equals sine 60. And then I multiply by the reciprocal of this on both sides. So that's going to be 4 over sine 40. So this is times 4 over sine 40. And then that makes this come out to B equals 4 times sine 60 over sine 40. And then that just gets tossed into a calculator. And if you do that, you'll get, let's see, B equals 5.39 to 2 decimal places. And then to get this third side, so we know B now, So to get the third side, I just do the same thing, but with c. So I can say, I'll slip it down here, sine of 40 over 4 equals sine of, ignore that, 80 over c. And so then I'm going to multiply up the c and then do the reciprocal of this. So same exact math over here. It's really repetitive, so this is what I'm pretty much doing every time. So c comes up, and then this is 4 times sine 80 over sine 40. And toss that in the calculator, and c equals 6.13. So the ones where we know two angles are actually pretty straightforward. You know, we can get the third angle easily, and then we just use law of sine twice, and that's it. Okay, so that example was both of these, because they can both be reduced to the same case. So the next three examples are side-side angle. These are a little bit harder ones. So there's three things that can happen. We could have a no solution, where basically the third leg of the triangle, based on the angle, isn't long enough to reach, and so you end up with no triangle. You can end up with one where, dependent, if the angle was here, we could have something here or here, and we end up with two triangles, or just the regular thing where there's one triangle. So on the homework, there isn't a no solution, but I'll include it just because it's one of the three possible outcomes. So this next example, number 2, is going to be a side-side angle, no solution. Again, you won't encounter these, but just to be complete, here it is. So if we're given a is 2, c equals 1, and then big C equals 50 degrees. So we have C and C, so we'll use sine of 50 degrees over 1, basically, equals sine of A, angle A, over 2. And so I'll bring up the 2 here. So this time I'm solving for sine instead of the side. So it'll look like this. And then those cancel. So I end up with 2 sine 50 equals sine A. And if you do 2 sine 50 in a calculator, and I'm going to write this in the other order just because I think it flows better. It's going to be 1.53 ... So the deal with sine is it has to stay, sine is always between, if you think of the unit circle, sine has to stay between 0 and 1, or sorry, negative 1 and 1. Because what sine is, for radius 1, sine is the y values. So here, when the angle's 0, there's no y, it's 0. We come up here, and for the unit circle, this would be 0, 1. So then sine is 1, and it goes back to 0, and down here it comes back to 0, negative 1. So the value of sine has to stay between 1 and negative 1, and we're outside of that range, so that tells me that this doesn't have a solution. Okay, so this is side-side angle, one solution. So this is kind of the normal thing that would happen. So we have A equals 3, B equals 2, and big A equals 40 degrees. So if we know that, we can do sine of 40 over 3 is going to equal sine of B, since I know side B, over, oops, that should be a 2. B is 2. I'll multiply up the 2, and I think I'm going to, again, switch the sides, so I'll write it as sine B equals 2 times the numerator, because we're doing this. So it'd be 2 sine 40 over 3. And then we throw that in the calculator, and we're going to get sine B is approximately 0.4285. I think I probably left that in my calculator out to more decimals. And then we do the inverse sine from the last section. And then that gets us the angle. So anytime we're looking to get the angle, we use inverse or arc sine. And if we do that, that's 25.4 degrees. Okay, so that makes this my first angle that's possible. So we'll call this one the first one. So for the second one, if I go 180 minus 25.4 degrees, that gets me 154.6. And so then that's my second angle. And let me make a little sketch to make that a little bit more clear. So right here I got 25.4 for my first one, but sine has two possible positive angles with the same value, and that's what we saw in the last section. And so the second one, I need x can be negative, but y has to be positive, right? So that means there's a second answer over here that is possible. And so if I go 180 minus 25.4, that means this angle right here would have to be 154. But the problem with that is I already have 40 degrees used up here. So 154 plus 0.6 plus 40, that's greater than 180 degrees. And so this one isn't a possibility because I would still have to have a third angle. So that means this is my only possible answer. And so that's what we do is we take this, we figure out where the second possible angle is, and we take it off of 180 and see if it works with the angle we already know. So this one doesn't, so second angle's out, and that means we just have this one. So that means I can find the third angle fairly easily. I can just say 40 plus 25.4 plus, we don't know, C equals 180. This is what I did the other time. This time I just showed some steps. So if I subtract these over, I get C equals 114.6 degrees. So now I have C right there. I have B. This one is angle B. So just to kind of summarize, now I have all three angles, and the only thing left is side C. So I'll do sine of 40 over A equals sine of 114.6 over C. And I'll do the same swap where I bring the C up and I flip this and bring it to this side. And that's going to be C equals 3 times sine 114.6 over sine 40. And if we tap that in a calculator, we should get C equals 4.24. Okay, and then this last one is an example of side-side angle 2 solutions. And so in this one, A is going to be 6, B is going to be 8, and big A is 35 degrees. So we have A's, so we'll do sine of 35 degrees over 6 equals sine of big B over the 8. Multiply up the 8, and again I'm going to write it the other direction. So sine B equals 8 times sine of 35 over 6. And if we toss that in a calculator, then that's going to make sine B equal, comes out about 0.76. And again, I just leave this on my calculator screen. And then I do arc sine or inverse sine of that value. and that gets me B. And so here I got B to equal 49.9 degrees. And so once we know that, so that's my first angle. And so the first angle, if I do 180, oops, let me draw that little picture so that makes more sense. So 49.9, that's something about there, basically 50 degrees. And so the other place we would have that is right here, because it has the same y value and the same r. The x doesn't matter because there's no x values in sine. So we're going to go 180 minus that reference angle, and that's going to give us that right there. So 180 minus the 49.9, and if we do that, that equals 130 degrees. 130.1 degrees. And so if I do, now this would be my possible second angle. If I do this plus my known angle, 130.1 plus 35 degrees, that is less than 180. It's like 165. And so let me go ahead and show that, less than 180. And so that would be 165.1 degrees is less than 180. So then that means the second side could actually happen. So for this side, I would have 180 minus 49 point, well, actually just minus the 165.1 because there's angle A and angle, A and B. So 165.1. And that's going to equal C. So that's 14.9 equals C. So there's my third side, but on my second version of this triangle. So we have two separate answers going. Over here, when B was 49, so then I'd have 180 minus 49.9 minus 35, and that will equal the C on the first side. And if we toss all that in, I think we get C is 95.1 degrees. So we'll call that one C1 and B1. And this is C2 and B2 right there. Okay, so to kind of summarize this last page, I got a little messy. So B1 back here was 49, and then that got me C1, which is 95. And then up here, we got B2 is 130, and that's because this other measure right here would be 130. And then that got us C2, which is the 14.9. And then these are givens. So what we still need is, and so these are two, like I said, separate problems now. And these go with both. So over here we have all the angles A and B, so we just need C. Same thing on this side for the second triangle. So here I'll do sine of 35 degrees over 6. So 35 over 6 equals, we need C, so sine of 95.1 degrees over C. And then the same little algebra flip, so I'm going to bring this and flip this over. So then C equals 6 sine 95.1 over sine of 35. And punching that into a calculator, I got 10.42. So then on this side, we'll do the same thing. Sine of 35 over 6 equals sine of 14.9 over C. And sorry, I should label that one C1 and this one C2. So this is C2 will equal 6 times sine 14.9 over sine 35. And that would be 2.69. So I think on the homework you'll see there's only 4 problems because these things are kind of gigantic. And I think it was number 11. I think it was the last one that's like this. I wouldn't test on this, but it's worth looking at just because it's a part of knowing the law of sines is that this can happen. And so definitely be using the answers in the back of the book because they're there to help you make sure that you know that you're doing it right or wrong.